Andy, can we start recording? Okay. So good morning. Today is Friday 29th. Okay. And today I'm going to try to be sure that everybody has a clear idea what's going to happen next week. Okay. That will take about 10 minutes. And then I would like to see to make a progress control of the report on the lab work that we developed last week. Okay, so I would like to know if there is any problem with the information that you have to analyze. Okay, that's the agenda for this morning. Okay, so next week is the fourth week after the first exam. Okay, this was we're going to have on Wednesday, people, Wednesday in the morning and also in the afternoon, you are going to have lab work, okay? I'm going to quickly explain what we're going to be doing, okay? It's very simple. And then on Thursday, the next day, Thursday, let me remind you, Thursday, the 4th, okay, of August at 10 a.m. Thursday, 4th of August, 10 a.m. Okay, we're gonna have the third quiz. Okay, so that's you knew about this the very first day of class, so there is nothing new. Now, is there any questions about that in general? Those two activities. Any questions about that? Wednesday and Thursday. Andy, did you have time to send the final schedule for each one of the groups?
I will present today, or I will send
Okay.
the afternoon.
Okay, I'm going to do it right now. Okay, I'm going to present the schedule that Andy and Maria Daniela, they have prepared for this for this lab. Okay, so let me see if I can find it here. Let me make it a little bit smaller. Smaller there. Okay, now I'm going to share. Can you see my screen, the schedule?
Yes, doctor.
In Excel? Okay, so as you can see here, we have 4, 1, 2, 3, and 4 time schedules, right? So, and Wednesday in the morning, we're going to start at 9. Since this first group, usually we have problems trying to set every equipment, right? I would like you to be here, not at 9, but at 8:30, okay? Please, here, groups 2, 3, and 10, try to be in the lab, say at 8:30, right? So we turn everything on, we check that everything is working correctly and all of that, right? Since you are the very first group, probably there could happen some problems, right? So we have to fix it and all of that. Usually that takes longer, okay? Then more or less that would take about 1 hour. And then we will go at 10, okay? From 10 to 11, we're gonna have groups 4, 6, and 5. And Mr. Dominguez, he had some problems, so he asked us to include him in the morning. So he's going to be in here. So we're gonna have 3 groups in every session. Then we have a noon break for going for lunch. And then in the afternoon, from 13 to 14, that's from 1 to 2 p.m., we're gonna have groups 9, 11, and 12. And then finally, from 2 to 3, we're gonna have 1, 7, and 8, okay? It is possible that this group here, the first session goes a little bit beyond 10, right? Because as I said before, usually the first group takes, has to fix some problems, right? So it is possible that this starts, the second session will not start at 10, but at 10:30, but you have to be here before that. Why? Because when these people, groups 2, 3, and 10, are in the lab, these others, 4, 6, and 9, and Mr. Dominguez, we're going to be similarly as in the first part of the semester. We're going to be in the auditorium. And I would like to ask just a quick question, so I will give you the opportunity to practice your English. That's the only objective of that. Okay? So that's for Wednesday. That's Wednesday, the 3rd. Okay, let me write here. Wednesday, just to make sure, August 3rd. Okay? Is there any questions about this, people? Is there any questions about this? Any questions about this? No
Excuse me, doctor. Excuse me, doctor. I have a concern. What will happen on Tuesday? There is normal class?
No. On Tuesday, you mean on Tuesday?
Yes, on Tuesday.
On Tuesday, we're going to have class at the normal hour. Yes, we're going to start chapter 5. Okay, that session is very just a description of the general structure of a ship. So there's not going to be a lot of mathematical relations or any physics or anything like that. It's just a very general description of some characteristic of a ship structure. But there's going to be regular class on Tuesday. Then on Wednesday, we're going to have the lab. On Thursday, we're going to have the evaluation, the quiz. And on Friday, we are not going to have class because we have 3 sessions already. Okay? Don't worry. All of this information I'm going to post in the Aula Virtual, right? So everybody knows where to go and at what time. Ms. Santos?
Okay, thank you.
No problem. Okay, so I'm going to write it here, Thursday, 4th. Okay, so we're going to have quiz. Okay, we're going to have quiz 3 at 10 a.m. Okay. Questions? Any questions? Everything is clear. No problem. Okay, so let's move on. So stop sharing. Okay, now let me have this. Okay, let's go randomly. My favorite number 12. Group 12. Who is in group 12? Anybody? Raise your hand if you are in group 12, people. So Ms. Acuña is here. Ms. Acuña, you are in Manta, right?
Yes, doctor.
You have to come next week, right? Now you do have to come next week. Okay, good. So I see Mr. Paredes is also here. Have you started to prepare the work to analyze the experimental results?
Yes, doctor.
Okay. So you have 2 parts, right? Simply supported and the
Or
clumped
unclumped.
experiment. So you have 2 parts. Who else is in your group? Miss Vanegas is also in your group, right? Mr. Vanegas, are you here? I think you're here. No. Mr. Vanegas, are you here? Mr. Vanegas, are you here? Yeah, you're here. Okay, so it's Acuña, Vanegas, Paredes, and Mr. Dominguez. Is this correct? Mr. Dominguez, are you here? Mr. Dominguez, are you here? No. Okay. So, tell me, Miss Acuña or Mr. Vanegas or Mr. Paredes, what have you done so far? Did you have any
analyze.
problems?
We divide the word and I start the analyze the data for the experimental results to the simpler support.
Okay, so you have that.
Mhm.
Do you need to use a program, okay? Who developed this program? Okay, you need to implement the problem, remember, for the previous homework, for the assignment to design the plate. You have to develop a computer program, okay? Who did that work?
Dominguez.
Okay. Now, so that's for the first part. For the other part, for the clamped part, I mean, when are you going to continue this work? Mr. Vanegas, do you know when are you going to meet again to continue with this work, Mr. Vanegas? Mr. Vanegas? Mr. Paredes? Mr. Paredes, I just want to see how you people are working in this group. That's all. I'm not trying to find anything strange here. This is just a question that I would like everybody to participate. That's all. Mr. Paredes.
Yes,
Or
doctor.
Mr. Vanegas. Could you please turn on your cameras, people? If I ask a group to participate, I need to see your faces. So I don't want to talk. Okay, Mr. Paredes, go on. When are you going to continue this work?
We divide the part the word. I am working in the clampet.
Okay.
Is Saline simple support in theoretical and Acuña in practice. In Benavide Vanegas practice.
Okay. Good. When are you planning to finish?
Today or
Okay.
Saturday.
Okay. Now, are you aware that you have to write, how many pages do you have to write for the report? How many pages? How many pages?
We don't start report.
Okay, but see, one of the things that we have to be aware is that the report cannot be longer than, how many pages? Anybody?
6.
How many pages? Exactly, 6. No more than 6 pages. Okay, so you have to put all of this information in 6 pages. That's all what you need to I mean, I'm not going to consider anything more than that. I am going to review, I'm going to grade this report. I don't have patience. I see more than 6, I just cross out, put 0, and that's it. Believe me, this is being recorded, so you are aware. 6 pages maximum, including appendixes. I am not going to read more than that. Okay? So you have to prepare yourself to summarize, explain all of this in no more than 6 pages, including the appendix. Okay, good, good. I like that you have organized this work, so everybody will have to participate. This is the clear teamwork. Okay, good. Okay, let's go to group. Let's see, group 9. Group 9. I see Miss Arechua, Mr. Andres Quimi, Mr. Andres Ortega, and Mr. Axel Cedeño. Group 9. Would you please raise your hand? Okay, Miss Arechua is here. Anybody else? Group 6, group 9, sorry. Arechua, Mr. Andres Quimi is here. Mr. Andres Ortega is not here. And Mr. Axel Cedeño. Axel Cedeño, are you here? No, we have only 2 people. Okay, tell me, Mr. Quimi, have you worked something? Can you turn on your cameras, people? Arechua and Quimi, could you please turn on your camera just for a second? Just to help me, because I don't want to talk to myself. Ms. Arechua, is it possible?
Good morning, doctor.
Good morning, Mr. Quimi. You are in Pozorja, right?
Yes.
Okay, so you are aware that next week you have to come to Guayaquil, right, for the evaluation.
Yes.
Okay? Okay, good. So tell me, what have you done to prepare the report on the plate bending report?
Yesterday, we told about the report because
Okay,
our group has flu. Me and my classmate, all my classmates. And
okay, so please, that's a good point, Mr. Quimi. Next week, people, everybody has to cooperate. Everybody. So you have to be aware that, especially during the lab work, since we are very close physically, okay, you have to wear all the time face mask. And you have to really wear it. Face mask. Okay, not here. It has to be here, really covering mouth and nose. Okay, so thank you, Mr. Quimi, for reminding me this topic. Okay, good. Ms. Arechua, how did you organize this work in your group, Ms. Arechua?
Yes. We organize for the calculus.
Okay,
We organize for the calculus. Ortega, Axel, and
okay,
me, and Kimi and Axel will do the objective and all that is theoretical.
okay.
And
now
the
go on,
program
go on.
is
Okay,
Ortega help us because he
okay.
knows more indeed.
Okay, so you have to be aware of something, okay? Since the programming part was part of what you are responsible, I am going to include, I don't know how many, but 1 or 2 or 3, whatever, questions about that in the evaluation. So everybody should try, I mean, that was part of the previous assignment. So there's going to be some questions about Python programming in the evaluation. Okay, so be aware of that. Okay, Mr. Quimi, when do you think are you going to finish to complete this assignment, this report, more or less?
maybe Sunday in the night. Because
Sunday night. Okay.
we're going to do today and Saturday and Sunday.
Okay, good. Okay, good. Okay, let's go on. Group number 7.
Present.
Okay, so I see Mr. Hidrobo. Would you please raise your hand for those in group 7? It's only you, Mr. Hidrobo?
I don't know if Nieto and Yadira and Medina, Williams Medina, are here.
No, I don't see him. I don't see them. Okay, tell me, what have you done about this report?
I was very busy programming. I like these things, and I know some things about programming, and I'm doing the program for simple supported analysis. And it's a little bit different than the homework just because some things I noticed and I want to, and I
No,
try
no,
to change.
just a second, Hidro, but I think it's the same.
Oh no! I mean, but because I have to analyze in one point and not make all the points in the plate. It's just in the extremes. Just I
Yeah,
need to change something.
Okay. Probably what you have to do is you apply the load here, but what you have to do is to ask the program to evaluate the bending moment in these points, okay, where you have located the strain gauges. Yeah, that's a little bit different, but that's all.
I want to change to ask again one question I've done before, because I want to be sure if just we have to only analyze the strain, compare the strain in the theory and the strains in the experiment. Just that, not other things like the displacement or other things.
No. If you want, you can plot it. But,
Okay.
But the objective is to check the analytical results with the experimental results. But you have only 4 values of strain. So all you need to show or to compare is the strain at these 4 points. That's all what you need to check.
Another question I have is the Autos program, the script you gave us. What are the outputs? The outputs are text, images, or plots?
No, the output is another. See, when you run this program, okay, you're going to have, say, they ask you how many partitions do you need in the X and in the Y directions, okay? I have tried this morning, I ran it with 51 partitions. So you have a lot of values, right? In the result file, okay, then you will see that there is a part when you have the X, Y position of each point, and then you will have deflection, bending moment, shear force, and then you will have stresses in the X and in the Y direction.
Okay, with
So
the
what you have to do is
with the stresses, I can calculate the strain in this, like the theory.
With this,
okay.
Yes, exactly.
Okay,
with
okay,
stresses,
thank you.
You can calculate it. No problem. Okay, and then what you have to do is you have the strain for different load, right?
Yes.
In the case of the theoretical calculations, what we can do is, see, you can apply the maximum load, okay? And then theoretically, if you apply a different load, you are going to have the result is going to be in the same line because this is a linear problem. Okay, let me see if I can explain this a little bit better. Okay, well, can you see my screen?
Yes, doctor.
Okay, so what we have is this. Okay, we have a plate. Okay, we apply, for example, in this point, we apply one value, and one value of force. So we have W1, W2, and W3, okay? And you have the strains here, 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 and here, okay? So what I would do is this, okay? I calculate for total W, okay? I have 1 epsilon, any one of these 4, okay? I can calculate. So when I do the calculation, I have a partition. See, for example, I have something like this. There. So this is X, this is Y. Now, for example, this value here is going to be close to this point here. This, of course, is going to be in the center, and this is going to be very close to this value. So you can take a sigma in this point, in this point, and in this point. With these values of sigma, you can calculate epsilon, okay? In this case, it's going to be epsilon Y, both, and this is going to be epsilon X in this point. Now, after you get all of this, you can plot. And what I suggest is that you apply in the program, you specify the combination of the 3 weights. So you're going to have a value, and you can join this with a line, right? Now, this is theoretically, okay? Now, let me change color. So I'm going to use this. Now, down here, I have the result from the experiment. See? From the experiment, I have, this is time, and this is epsilon. Okay, so we start, then we go, then we go, then we go, then we go down, down, and down. Okay, so you take this value here, which is very close to 0, then you have an average, and so on, right? So we will have in the same plot, we're gonna have results for W1 plus W2, and finally for the 3 weights together. So this value here and this value here is going to be for W1. So you're going to have 2 values. So let's suppose that I'm here and here. For this value, I'm going to have this and that value. So I'm going to have, let's suppose I have this and that. And finally, from this average, I will have something like this, right? Now, for the 0, I'm going to have this and that. So let's suppose I have this and this a negative value. Now, after you do this, you can generate a linear regression. So this is linear regression. Okay, now you're ready to compare. Mr. Hidro?
Yeah, it's really necessary to do the linear regression where, for example, I know that in Python we can make step functions with some points. And
No, I think it's better to do a linear regression because in this case, since we are developing a linear analysis, we can expect this experimental result being related by a line, definitely,
okay.
definitely. Okay.
Doctor,
Yeah, go on.
I have a question. It's about for the program that you gave us. Because I was trying to work yesterday in that, and I changed the values for K. But when I plotted, I tried to read the TXT document, but I don't know what is what. I can understand. Maybe you can show us because I have a lot of values, but for example, in the in the axis where say, for example, normal moments in X, moments in Y, I have NAM, like nothing, any value. And I don't know what is that. Maybe you can give us an example, like how we can use that.
Okay, I can try to see. Let me see if I can find. Here it is. Let's see if I can make this a little bit smaller. A little bit smaller. Okay, let's see if I can share my screen. Okay, can you see this file with the results?
Yes.
Okay, so this is just the part of the results. Okay, let me try to reduce the size. There. Okay, now, if you see here, okay, this is an exclamation mark and the same in this line. Okay, why do I do that? Because I use a specific program just to plot this information. But this is the information that I obtained. Okay, so here you see that this is the position X for each one of these points, these joints. This is the Y position, and then you go deflection, moment, this is the torsional moment, shear force, and the stress in X and Y. Okay, so that's what I mean. Okay, so what you can do is you can identify, in this case, I think I employed 51 partitions. So you can estimate with this partition in what point is closest to the point where you measure the strain. And get it, after you identify that, you can select the line, and these are the stresses in X and in Y that will allow you to calculate the strain in this point. Mr. I forgot who was speaking.
Benavides, Doctor,
Benavides.
But the thing is, I did that and I got TXT documents similar like that. But in all the values, for example, in W moment shear,
Okay.
I have NAM. This word.
No, that means that there is something strange with that's something wrong with the data.
With the data.
Let me see. Yes. See usually, let me open my data file so you can, if I can find it. Let me see if I can. Can you see my file? This is my data file. Okay. And these are the dimensions. These are the dimensions of the plate. 3 millimeters in thickness. Young modulus, Poisson ratio. Remember, this is not steel. In the clamped case, it was aluminum alloy. Okay, and then I had problems because these values, okay, there shouldn't be 0. Okay, because when it calculates, there is a quotient. So if you set all of these exactly equal to 0, you're going to have something like a division by 0, and that will give you infinity.
Yeah, I
okay?
put that here in that values. And I can put that.
So in this case, for example, this value is going to be 0.01 millimeter. So basically, that's nothing, right? Now, the rest is equal. There is no uniform distributed load, and you have a concentrated force at this position, 0.58, 0.3, that's X and Y, and this is the value in newtons of the force. So this is the summation of the three weights.
Okay.
So this is the, go on.
And yeah, now I understand this. And my other question is where we are taking our reference system.
In a corner, left corner.
Left down corner.
Yeah.
And you told us the last class that because, for example, if we put the values of n and m, for example, 20, we're gonna have 24, for example, yeah, 24 and 24, yeah.
Yeah.
And when we start to analyzing the data, we take after 4, yeah.
Yeah.
And for example, our zero now is in 4, for example, and in that point we're going to start to count the values, yeah.
Exactly. Yeah.
Okay.
Yeah, but you can calculate the spacing because you know A, you know B, and you specify the number of points that you're going to have in X and Y. So, for example, if you say that you need 3 points in the X direction, and the dimension is 1 meter, the spacing is going to be 0.5. So it's going to be 1 meter divided by the number of divisions, the number of points minus 1. So
Yeah.
you know the spacing, and you can figure out. And for example, this is something, I don't know, maybe you can talk to Andy or Maria Daniela. Okay, this is the result. Let me show the result here. Can you see my result here? Zillions of points of little circles in blue. Can you see, Andy? Can you see this? Okay.
Yes, Dr. Vicasi.
Now, okay. Now here, this is easy plot, right? So you see, this is X and this is Y. Okay. So you see that I have 1, 2, 3, and up to here, I think it's 51. Similarly for in the Y direction. Now, he can explain it to you, but what I did was I let EasyPlot to know that this is a 3D information. Okay, so can you see my style option here? And I choose 3D. Can you see this?
Yes.
Okay, so if you do that 3D, this is what I obtain. Okay, and now with these arrows, I can rotate it. So in this case, this is the stress that I'm plotting. Yeah, and you see immediately that in the position where I apply the force, of course, you have a very large value of stress. This is a very high value, but it still is not correct because you're going to have a very extremely large, since this is a concentrated force, right? But in this case, this value, this is for the stress, okay? This is going to be a good, a good approximation, okay? Similarly, in this point here, you're going to have a good approximation. And in the center, you're going to have a decent approximation, okay? So that's what I wanted you. So if you want, you can talk to Andy, and he can explain it to you. So you can rotate the plot so you can see it from different directions if the plot makes some sense or not. Okay. Some years ago, we bought the license to use this program. Okay, so since that point, we have a lot of experience using it. Okay, so it's quite useful. Okay, or you can directly plot it with Python facilities. So that's what I use in order to see the distribution of these variables, of these parameters. Okay, so I think it's I just make a quick estimation this morning, and I think the result was very good. one of the values that I compare. See, what I did was I was comparing on the one of the points close to the border, but you have clamped. I did not compare it in the center, which is very tricky because it's close to the point where the load was applied. But yeah.
For example, doctor, and the thing that you told
Yeah, go on.
now is when we have values, for example, when we apply a load near to the center of the plate, the deformations are gonna be really small, yeah, and just for that, and at the strain
No.
gauges that.
Not necessarily, because if you have a plate and you apply a concentrated force here, see, please try to not just work this mathematically, but try to think this physically. Okay, I've applied this. Okay, you say this is a very large value in this and a small area. Okay, but if you can see this point here, and still this area, which is very small, it's a infinite larger than the way you apply a load as in a concentrated way. Concentrated way means that the force is applied in an area which has an area, a value of area in the limit when it tends to 0. So it is an extreme case. So I don't expect to be that small close when you apply the force close to the center part, because it's mathematically it's an extreme. So I don't expect the values to be that small. I expect the values to be small when you are on the close to the edge in the direction of the longest side. So that's epsilon x. That value is going to be very small. But epsilon y, okay, in the direction of the shortest side, that's going to be very large too. We'll still have to see what happens with epsilon x in the center of the plate. Why? Because that's very close to the place where you apply the concentrated force.
Okay, thank you.
Okay, so see, try to keep in mind that this is physics. This is a very small area, but still, this area is infinitely large with the delta Dirac function. So mathematically, it's an extreme. Okay, physically, I mean, you can never have a situation when you have really a concentrated force, because you always apply a force. For example, the weight of a winch. Yeah, you see the profile of the ship, right? Say a ship which is 60 meters long, and the winch in the forward end of the ship is maybe 1 meter long. So you see 1 in 60 is very small, but still the area where you apply, even though it's small, is finite. Maybe 2 square meters. But in the limit, we simply consider that as a concentrated force. So please, let's start. The physics gets into your mathematical results. Okay, so yeah, I would expect the results around the center part of the plate to be decent, not neglectable. Because when you apply this force in a concentrated way, you are taking it to the limit. Okay, is there any other question, people? Any other question? I would like to go to the last group. Just we have to end up at 11:28 because this office is going to be used by somebody else. Okay. Just to complete, let me see if I can ask another group. Let's go to group 2. I see Yangare, Ms. Aviles, Mr. Sawai, and Mr. Aizaga. Is there anybody from that group in here? Yangare, Avilés, Zaguay, Aizaga. Anybody? Raise your hand.
I think it's not here,
Oh, man.
this group.
Okay, let's see to group 1. Jerry Cedeño, Daniela Santos, Mr. Tenemea, and Mr. Carranza. Is there anybody here? Group 1.
Yes, doctor. Good morning.
Good morning, Mr. Carranza. How is this work coming? Is it coming on time or what?
In the group, organize the information in the program Python.
Okay.
Is the work is prepare the Dairo Telemea. I explain you the information that work.
Okay. And have you seen the experimental results? Have you plotted the experimental result?
No, I'm comparing the Saturday.
Okay. Oh man. Just a second, please. People, if you want, I can prepare a session on how to use EasyPlot in order to do some of this work. Okay, I can give you a short explanation on how to use EasyPlot. Okay, because in EasyPlot, I can take these values, I can make a plot, I can make an average, I select a range of values, and I can make an average quickly. Then you can plot the whole thing and all of that if you want. Okay, I'll be in this session at 5 p.m. this afternoon. Okay, those who want to come, and I'll try to explain as soon as I can. And then there is a manual I can share. I can put it in the Aula Virtual, and also there is a program, EasyPlot program. I can also put it in the Aula Virtual, right? So I can show you if you want. So in order to analyze these experimental results, it's quite useful. But if you want to use Excel, that's also, and you can use it. But the problem with that is